Today's lesson is adding and subtracting rational expressions with unlike denominators. So the first thing you want to do is to find your least common denominator. So when you're looking at number 1, you will see you have 8x and 6x squared. So the first thing you want to look at is those coefficients and say, all right, well, my least common multiple of those is going to be 24. And then you're going to look at the exponent or the variable with the exponent and say what is the lowest or the highest degree in the exponent, and then kind of match that. So it's going to be 24 is my coefficient and then x squared, since that one right there has the highest degree that you have to match. So treat them just like fractions. Say, what does this one need to make it equal this, and what does this one need to make it equal this? So when I'm looking at the first one, 1 over 8x, it needs a 3x in order for it to be that 24x squared. So I'm going to multiply numerator and denominator by 3x, just like with fractions. So 3x over 3x. The other rational needs just a 4, so I'm going to multiply it by 4 over 4. So here you're going to have 3x over 24x squared plus 4 times the quantity of x minus 2 over 24x squared. So I'm going to distribute that 4 to both terms here, and I'm just going to rewrite everything over one denominator here. So you're going to have 3x plus 4x minus 8 over 24x squared. Combine like terms, your answer is going to be 7x minus 8 over 24x squared. You cannot factor the numerator, so it is in its simplest form. All you have to do is state your excluded value. So in this one, x cannot equal 0. So now looking at number 2, you have that 3x squared, or 3x cubed, and a 9x squared. So here you're going to have to try to figure out, well, what is the coefficient, LCD, or coefficients, least common multiple, and then what is also my x's, my variable's least common multiple. So pause the video, see if you can figure out what that least common multiple is, and then unpause it and you'll see the work. So you should have gotten 3x plus 15 over 9x cubed minus 2x over 9x cubed. So here we're going to combine our like terms. We're going to get x plus 15 over 9x cubed, because your like terms are the 3x and the negative 2x. So the only thing left to do is state our excluded values. So x cannot equal 0. So in the next problem here, it's a little bit different, as our denominators are two binomials. So in this type of problem, you're actually going to have your LCD is going to be each one of the binomials. So it's this one here is going to need a k minus 2, and this one here is going to need a k plus 1. So your LCD is actually that k minus 2 times the quantity of k. Those are x's. Okie dokie. Well, you know what I mean. Plus 1. So this first one, I'm going to multiply numerator and denominator by k minus 2 over k minus 2. This second one, I'm going to multiply numerator and denominator by k plus 1 over k plus 1. So here it's really important to remember to distribute these values here. So this 2k to the k minus 2. So when you do that, you're going to get that 2k squared minus 4k, and then plus, and then you're going to also want to distribute this k to both terms. So k squared plus k. All of that is going to be over k minus 2 times the quantity of k plus 1. So your next step is going to be to combine your like terms. You're going to get 2k squared and a k squared. That's going to give you 3k squared. And then you have a negative 4k and a positive k. So it's going to give you a negative 3k over k minus 2 times the quantity of k plus 1. In this one, it is important that you factor your numerator. I see a GCF of 3k, so I'm going to factor that out just to make sure that I can't simplify this rational expression anymore. So I'm going to do 3k times the quantity of k minus 1 over k k minus 2 times the quantity of k plus 1. There's nothing to simplify there. So now I do know that it is in its simplest form. So the last thing I have to do is state my excluded values. So k cannot equal -1 and 2. So let's take a look at this next problem. It's going to be kind of similar, except you'll notice in the denominator there is something that can be factored. You always want to factor first so you can see what your common binomial factors are so that you can figure out what your LCD is. So here you have a y squared minus 64. That's a difference of 2 squares. So this factors into y plus 8 times the quantity of y minus 8. Right there you can see something you have in common. You've got these y minus 8s. Y plus 8, excuse me. So that's one piece of your LCD. So if we're looking here, your how many crickets? Your LCD is y plus 8, because they both have that in common. And then what one has that the other doesn't then is that y minus 8. So you're going to multiply this first one here by nothing because it has your LCD. So that's going to remain 3y minus 1 over, and I like to just keep it in that factored form, y plus 8 times the quantity of y minus 8, just in case I can, factor it later at the end, and then I can figure out what can be simplified. So here, this one has the y plus 8, but it needs that y minus 8. So that's what I'm going to multiply numerator and denominator by. Y minus 8. So you get 3 times the quantity of y minus 8 over y plus 8 times the quantity of y minus 8. So the first thing you're going to want to do here is definitely distribute that -3 to both terms. So I'm going to leave the first one alone. I'm going to leave it as 3y minus 1 over y plus 8 times the quantity of y minus 8. And then I'm going to distribute that -3 to both terms. So -3y plus 24 over that y plus 8 times the quantity of y minus 8. So in this instance, you can actually you can put it all together and just make it over one denominator. That's fine and combine your like terms. I just happen to put it over like each one separately. So now I'm going to look and combine my like terms. I got a 3y here and a -3y. They're going to cancel each other out. So I'm left with just a -1 and a positive 24. So it's going to give me 23 over y plus 8 times the quantity of y minus 8. So there is nothing to factor in the numerator. So your last step is to write your excluded values. So y cannot equal plus minus 8. So take a look at the next problem. See if you can figure out what your LCD is. The first step is always to factor that denominator. So if you pause the video and try to factor that denominator and multiply by which one they need, you'll see the answer when you unpause the video then. So you should have gotten the LCD as x minus 6 times the quantity of x minus 2. You'll notice that when you factor that first trinomial here, you'll get that x minus 6 minus x minus 2. So in the second one, you have the binomial of x minus 6. So all that one needs is the x minus 2. So I'm going to multiply numerator and denominator by x minus 2. So the first rational expression stays as x plus 3 over the quantity of x minus 6 times the quantity of x minus 2. This one becomes -2 times the quantity of x minus 2 over x minus 6 times the quantity of x minus 2. So now I have my common denominators. Now I can put my rational expression together. I can subtract it. First thing to do, distribute that -2 to both terms. So you're going to have x plus 3 over x minus 6 times the quantity of x minus 2. And actually in this one I'm going to just keep it all over one denominator. So -2 times x gives me a -2x. -2 times -2 gives me a positive 4. So now I'm going to combine my like terms. I'm going to get -x plus 7 all over x minus 6 times the quantity of x minus 2. So there's nothing to factor in your numerator. There's nothing that can be simplified. So the last step is to state your excluded values. So x cannot equal 2 and 6. This last one is a little bit different than all the other ones. So in this one, you're looking and you say, okay, well, I see stuff that can be factored. Always factor first. So if you have b squared minus 2b, I see a GCF of b in both of those. So I'm going to factor out that b times the quantity b minus 2. And then the next one, b squared minus 4, that's a difference of 2 squares. So I'm going to factor that into b minus 2 times the quantity b plus 2. So when I look at this now, I can see one thing they have in common is going to be that b minus 2. They both have that. So I know that's part of my LCD. So LCD is going to be that b minus 2. So now I look and I say, all right, well, what does one have that the other doesn't? Well, in the first one, it's got that just value of b. And then in the second expression, it's got that b plus 2. So here, I have to go through and I say, all right, so the first expression has b and the b minus 2, so it needs the b plus 2. So that's what I'm multiplying numerator and denominator by. The next one has both the b minus 2 and b plus 2, but it doesn't have the b. So I need to multiply numerator and denominator by b. So here you're going to have, if I rewrite this whole next one, you're going to have b minus 3 times the quantity of b plus 2. All of that over b times the quantity of b minus 2 times the quantity of b plus 2. The next one, you're going to have b times the quantity of b minus 4 over, because I'm multiplying just numerator and denominator by the b times the quantity of b minus 2 times the quantity of b plus 2. At this point, I do want you to pause the video, and I want you to solve this one. I want you to distribute everything, combine all like terms, and then simplify everything and state your excluded values. Okay, so pause the video, try to do that, and then unpause for the final answer. Okay, so you should have gotten 2b squared minus 5b minus 6 over b times the quantity of b minus 2 times the quantity of b plus 2. In this one here, you can't factor the numerator, so it is in its simplest form right now, and that's it. So when you're doing these, the key piece is to make sure that you think about least common denominators and factor everything. Factor before you start. Think about those least common denominators and think about, what does this rational expression need that one has? What does the other rational expression need that the previous one had?